All right, imaginary numbers. This is lesson 2.4. So at the top, go ahead and write 2.4 imaginary numbers. Imaginary numbers. It does sound fun.
I've been looking forward to learning about these since Algebra 1B.
Okay, so imaginary numbers, we come across them when we have equations such as x squared plus 1 that have no real solution. Okay, because if I tried to solve x squared plus 1, if I got x squared by itself and that became negative 1, to get the square off, I have to take the square root. And you can't take the square root of negative number, right? If you try to do that in your calculator, if you try to take the square root of negative 1 in your calculator, it comes out and it says error. You all see where the square root button is on your calculator? To the left of, is it the 7? You have to hit second and then the x squared key. You guys see that? Second and then this x squared key, and it says domain error. Okay? So what happens, the imaginary unit, we're going to use the lowercase I, is defined as the square root of negative 1. So the imaginary unit I is defined as the square root of negative 1. This is useful when working with square roots of negative numbers, so when we get a negative number, we can go ahead and keep going. All right. A pure imaginary number is written in the form the square root of negative 1 times a, where a is the real number and negative 1 is the imaginary part. Okay, so the first thing that we're going to do is we're going to rewrite these statements, okay? So the square root of negative 9 really means the square root of negative 1 times 9. Okay, so let's go ahead and rewrite that as the square root of negative 1 times 9. We're on page 12, ladies. So the square root of negative 1 times 9, go ahead and write that. And then what is the square root of negative 9? I'm sorry, of 9? 3, right? And we already said negative 1 times 9. So we already know that the square root of 9 is 3. And we said that the square root of negative 1 is the same thing as writing I. So this becomes 3I. What if I said over here the square root of negative 25? Well, the first thing to do is, again, we have that negative, so we're going to pull the I out, if you want to consider it that way. And so we could rewrite this as I square root of 25. And the square root of 25 is what? 5. So this is 5I. Yesterday we learned about how to break down a radical, right? So is 196 a perfect square? Well, first, we can't take the square root of negative 196, so the first thing we're going to do is take the I out. So it becomes I square root of 196. And then in my calculator, I'm going to check to see if 196 is a perfect square. If you need a calculator, there's some in the box up there on my desk. Is 196 a perfect square? Don't think. Use your calculator and figure it out. Try it again. The square root of 196. You guys said it comes out evenly to be 14, so this becomes 14I. We treat I like a variable kind of when we always put it after the number. Okay? What about number 3? Again, if you see a negative, the first thing to do is to take the I out. Are you saying huh on number 3?
Oh, no, I'm just trying to show you the right
So we have
number.
I square root of 5. Is the square root of 5 a perfect square? No. So we've taken the I out. We've simplified it. This is going to stay as is. I square root of 5. Okay. What about number 4? What's the first thing we always do?
Bring your eye.
Take the I out. Okay. So if we take the I out on number 4, I have I square root of 80. We learned yesterday how to break this down, didn't we? What do? The little ladder factoring tree kind of thing, right? What two numbers multiply to get 80? 10 and 8 is what I heard. Okay. Do you have to use 10 and 8? No. Okay, so let's use 10 and 8. That gives me 2 and 5. 2 and 4, and then 4 breaks down to 2 and 2. What are we looking for now at this point? Pairs of two things, right? So I have a pair of 2's here. And I have another pair of 2's. For every pair, you write it where? On the outside. So I have 2 pairs of 2. So on the outside, I'm going to write 1, 2, and another 2. What else is outside? The I. Good. And then what did not get broken down? The 5, right? That 5 doesn't have a pair. The 4, all right, so maybe sometimes it looks a little bit tricky, but the 4 got broken down to the 2's, right? So the 4 is really gone. So because the 5 did not have a pair, the 5 goes back inside. What do you think we need to do with the 2 and the 2? Good, we're going to multiply them. So 2 times 2i is going to give us 4i square root of 5. So the purpose of using I is so that we can continue to go through the problem and not get stuck. Because if I take the negative out, if I take the I out, then I can continue as normal like we did yesterday. All right? So let's look at number 5. You try number 5 and see what you can do. The first thing to do is to pull the I out, right? Okay, try that on number 5. Try that on number 5. Breaking 32 down. This is kind of a big tree. I'm going to do 4 and 8. Any which way you do it, you should end up with 5 2's at the bottom. No matter what numbers you use, you should end up with 5 2's at the bottom. Okay? So if I have a group of 2's, I can group them together, and another group of 2's. What goes on the inside? A 2, right? There is still a 2 left over that didn't get used. And so what's 2 times 2i? 4i square root of 2. Good. Any questions so far? Okay, why don't you try number 6?
Squaring an item multiplies it by itself, correct? Thus times 2, basically.
Not times 2, times itself.
Oh, times, it's still multiplying it by itself twice.
Okay.
So in that theory, if we simply did the remove square root method, we'd have a double number, but that would successfully get rid of the negative sign, wouldn't it?
And that's what we're going to do in the next part of the lesson. Yeah, Mitchell?
What do you do when you don't get anything on that?
Okay, you didn't get any numbers for 192?
No, on the inside.
Oh. Is 192 a perfect square? Okay, so Mitchell, what two numbers did you use at first?
I use 96 and 2.
96, oh. Okay, and then what'd you do for 96?
Broke it down 48 and then did 8 and 8 and then did 2 and 4.
Okay, what'd you break 48 into?
48 and 2.
Okay, and then what'd you...
Broke it down to 8. What did?
8 times 6.
Yeah, my bad.
2 and 3. 4 and 2, 2 and 2. It's a lot of pairs. So I have a pair of 2s, another pair of 2s. I should have 3 pairs of 2s no matter which way I broke it down. Is that what you guys have?
Yep.
3 pairs of 2s. So that means on the outside you're writing 2 times 2 times 2. I, square root of 3 is the only thing that's left. This 3 right here is the only thing that didn't get combined. What is 2 times 2 times 2?
8.
8, not 6, right? It's 8. So then you have 8i square root of 3, finished. You guys okay with that?
Yeah.
All right.
But would we use that method to get rid of a negative sign under the radical, or will we still be using?
I'll show you. I'll show you. So let's look at number 7. If I were to solve number 7 for x, if we're going to get x by itself, okay, notice that none of these problems, 7 through 10, have that middle bx term, right? We have ax squared plus bx plus c. All of these problems have the x squared term, and then they all have a constant, a number, right? So it's kind of different than the ones that we did yesterday. So today, what we're going to do is we're going to get x squared by itself. So in number 7, if I want to get x squared by itself, I'm going to subtract 81 from both sides. And now I have x squared equals negative 81. How do we get rid of a square? Not divide,
A quadratic formula.
not the quadratic formula.
Do you need to like break it down? into eggs?
Nope. Okay, so the opposite operation of squaring something is taking the square root of something. All right? So if I want to take this squared off, if I take the square root, what happens is these two things cancel each other and I'm just left with x. That's how you get rid of a square. But whatever you do on one side, you have to do on the other side. So on the other side, I have to take the square root of 81, negative 81. And we just, it's not negative 9. What do you have to do with a negative? Take the I out, right? So then this becomes I square root of 81. It's not negative 9, because what is negative 9 times negative 9? What's negative 9 times negative 9? Positive 81, which is not negative 81, right? So now, what is this? Now that we have the I out, what's the square root of 81? 9. So we can say 9i. But we really need to say plus or minus 9i. And I'll explain why. It's not a big deal. Relax. Positive 9i is one answer, negative 9i is one answer. Because if it's x squared, that means I need two answers. Okay? If you guys think about this, the square root of 81, you've always been told it's 9, right? Because we know that 9 times 9 gets you back to 81. But is it the square root of 81? Can't it also be negative 9? Because what is negative 9 times negative 9? Positive 81, right? So either one, positive or negative 9, if you square it, you're getting 81, right? So that's something that we don't teach you until you get to Algebra 2, because we just want you to be able to get the square roots down as you're progressing through algebra. But really, every square root has two answers. So what would the square root of 25 be? 5 and negative 5, right? What about the square root of 64? 8 and negative 8. So the square root of negative 81 is positive 9i and negative 9i. Okay? So we're just changing a little bit. All you have to do is put a plus minus on top of each other. Let's look at number 8. We're going to solve for x. So what do we need to do first? Subtract 9. Okay? So I get 2x squared equals negative 8. Before I can touch the x squared, though, what do we need to do? Good. Good. Divide by 2 on both sides. Okay? Gives you x squared equals -4. Okay, and then Brooklyn said we need to take the square root of both sides, right? Because to get rid of that square, we have to take the square root of both sides. So this cancels. That gives me x. It's not -2. What do you do with the square root of a negative number? I first. I squared root of 4. Guys, there's a reason that we're taking notes, so that when you're doing your homework, you can go back and look at it. What is the square root of 4? 2. So this is x equals 2i. But what do we have to remember? Plus or minus 2i. I'd like you to try number 9 on your own, please.
Okay, so would you always have the plus or minus?
When you're doing the I. Yep. Yeah, just like this. Yep. Try number 9 on your own, please.
So
You're not showing any work, so I'm concerned that when you go back and look at your homework, you're not going to know what to do. Go as far as you can. If you can.
So if you can't break it down, does it just stay the same?
Yep, it just stays as the radical. Good.
I just find it kind of disappointing that the big secret to simplifying a negative number into the radical is just say, you know what, we don't know what to do, let's just throw an I on the outside and say that's...
Okay, so raise your hand if you're to this point at least. X squared equals -6. You're at least there. Okay, now how do we get rid of that square? Take the square root of both sides, right? Okay, and that cancels here. So I get x equals the square root of -6. And I heard someone say take the I out. Okay, so that gives me x equals I squared root of 6. Does the square root of 6 break down? It does to 2 and 3, but there are no pairs, right? So this one can't break down anymore. So we just leave it as I squared root of 6, but what do we need to put in front of it? Plus or minus I squared root of 6. Taylor?
Why is the I before the root and not the after?
You mean like this square root of 6i?
Yeah. Now would that be right?
As long as I can see that there's a definitive break here, because if you allow your if you allow your square root to go over the I, it's going to be the wrong answer. But you will never see it like the way that you just said.
Okay.
You'll always see the I in front. Okay? So you want to make sure that you do it that way. Okay, try number 10 now.
I'm confused now. I thought the I always went behind and then.
It does unless there's a square root still in the answer. If there's a square root still in the answer, it goes in the front. Okay? Okay, try number 10, please. Did you get number 10 already done? Can 12 break down?
No.
And where's your I at?
Oh.
You might want to see if 12 can break down. You might want to check to see if 12 can break down. Okay, getting there. I see most of you are here. X equals the square root of -12. We know if -12, that means we take what?
The
Okay, you guys are getting good at that part. And then if I want to try to break the square root of 12 down, what two numbers make 12? 4 and 3, 6 and 2, either one. 2 and 2. Aha. Correct. So I have a pair of 2's. So this becomes 2i square root of 3. What goes in front?
Plus minus.
Plus or minus.
Does it matter if you choose in front or back?
I want it in front because if it's in back, it'll probably get multiplied times the 3. And that's not correct. Okay? All right. Let's go over to page 13 where it says powers of I. Sometimes we're going to see I to a certain exponent. So you might see a problem that just says like I to the 15th, I to the 4th. What does that mean? There's a pattern. Okay, so Crystal kind of alluded to this before. We talked about I to the first power is the square root of negative 1, right? We talked about that's what I means. I means the square root of negative 1, and I to the first is just I. I squared, and this is I think what you were alluding to, the square root of negative 1 times the square root of negative 1. Well, anytime you multiply a square root times itself, you just get negative 1. So anytime you see I squared, you're going to change it to a negative 1. That, my friends, is the biggest one that you're going to need to know about. So I would highlight, if you can, or circle or something, I squared is the one you need to know about. It's always going to be negative 1. That's the one we're going to use most often in this class, I squared. Okay? I to the third is like saying the square root of negative 1 times the square root of negative 1 times the square root of negative 1, which gives you, you don't have to write that part down if you don't want to. Yeah, no, square root of negative 1 times the square root of negative 1 times the square root of negative 1 does not, it's not a positive one. It's negative square root of negative 1. That's what it comes out to be. Negative square root of negative 1. That seems like a lot to have to write. What did we say just a few minutes ago? What is the square root of negative 1? It's I, right? So this is like saying negative I. So that's how we write this, negative I. So whenever you have I to the third, you're just going to write it as negative I.
But wait, that's a double negative because I stands for
It's not
negative
it's
number.
not a double negative. I stands for the square root of a negative number. Okay? And I to the fourth is going to be 4 of these, right? Square root of negative 1, square root of negative 1, square root of negative 1, square root of negative 1. Which really is just positive 1. So I to the fourth is going to always be positive 1. The one we're going to use the most that you need to focus on is I squared. Okay? Here's the cool thing that happens. I to the fifth, and I'm going to write it out like this. I to the fifth is really 5 i's, right? That's what I to the fifth means. Do you guys agree with that? Okay? Every group of 4 kind of cancel each other out, and you're looking at the remainder. How many i's do you have left? 1. So this is really I to the first power. I know it is confusing, so we're gonna keep practicing and you're gonna get it, I promise. I to the sixth is 6 i's, but we're looking for a group of how many? 4. There it is, it's gone. How many are left over? There are 2 left over, right?
Actually,
So it's I to the second, and what did we say I to the second always is? Negative 1 always. Hold on to your thought. Now, hold on to your thought. Without writing out 7 i's, how many times does 4 go into 7? one time, right? And then how many are remaining? 3, right? Because if you take away 4, you get 3. So this is the equivalent to I to the third, but what did we say I to the third really was? Negative I. What about I to the 8th? 4 and 4, right? And there's nothing left. It goes evenly. So when it goes evenly, it's like saying it's I to the 4th, which is 1. So every 4, the pattern repeats. All right, so let's talk about this. I to the 15th. You're always looking for the remainder. How many times does 4 go into 15? 3 times to 12, right? 4 times 3 is 12. So if we take away 12 I's, how many are left?
2. It's negative.
Woo, careful. There are 3 left, right? 15 minus 12 is 3. So if there are 3 remaining, that means this is really I to the third. Good, which is negative I.
Actually, that makes sense, and I'm not sure if this is the proper way to think of it, or this is how I picture it. With the I to the 5th, basically, if it kind of works out as 0 pair, because there's because 2 negatives equal a positive when multiplied, and those are square rooted, which basically they multiply by themselves. It works in my head.
Okay, that's where we're going to stop then. That works then. Okay, we're going to keep doing some more of these. This is always the hard thing for students. I to the 62nd. Now, I'm not asking you to know how many times 4 goes into 62, right? Because that's beyond the 40s, and then you're getting to like 12, 15, 16. So let's take our calculators. Let's take 62 divided by 4. What is 62 divided by 4?
15.5.
15.5. So we want to be looking at the remainder. Okay, so 0.5 is what we don't care about the 15. We're looking at how many are left over. 0.5, okay, is like 50 cents. How many quarters is 50 cents? 2 quarters. So that means that there's 2 left. So this is really I squared. Okay, we are going, guys, listen, if you say that you have no idea what's going on, it's okay. We're going to keep working. I'm not leaving you hanging. Trust me. And then we said I squared always turns into what?
-1.
There we go, -1. What I'd like for you to do on the side right here, I want you to put 0.25 next to I to the first. 0.5 next to I to the second. What do you think I to the third is going to be? 0.75. And then 1. So if you're going to use your calculator and you're looking at the remainder, this is going to tell you which ones go where. And it's only based on the remainder. So over here we're going to write some more examples. So let's write I to the 103rd power. I'm making them big so that you can understand our process. We're always dividing by 4. So take your calculator. 103 divided by 4. We're looking at the remainder.
0.75.
0.75.
So it's I to the third.
So
which
it's
is
I
really
to the
negative
third.
I.
Okay, so let's back up a little bit.
Boom, got it.
103 divided by 4, we're always divided by 4, is it 25.75? So we're just looking at the remainder. It's 0.75. Think about it in terms of quarters. How many quarters is 75 cents? 3, right? So this is really I to the third. And we said I to the third is always written as negative I. Okay? Let's try another one.
Good job, guys.
I to the 78th. I to the 78th. Write that down. Use your calculator. Do not shout out the answer, please. You're always dividing by 4, so 78 divided by 4. Look at the remainder. See how many quarters that is. So Lexi, I to the 78th reduces to really to what? Lexi? I squared? Lexi, what is I squared really? -1. Anybody else get I squared on that one? 4 of you? Good. Okay. It's like pulling teeth from you. One last one. I to the 400. Vinny, what'd you get?
I just got 1.
Okay, so when you did I divided by 4, or 400 divided by 4, it came out evenly, right? And when it comes out evenly, it's really I to the what?
Oh, I to the 4th.
Okay, it's really I to the 4th because there is no remainder. And I to the 4th is 1. Anybody else get 1? Okay, is this helping a little bit more now that we've done a few more?
Yeah.
Some of you, yeah? We're going to do some more practice. I would make yourself a note at the top and say, always divide the exponent by 4. Okay, always divide the exponent by 4. And then you have your 0.25, 0.5, 0.75, etc. All right, let's go ahead and simplify some in 15 and 16. It says simplify the expressions below. If I said 4x times 7x, what would the answer be? Think about this. If I said 4x times 7x, what is your answer? 28x squared, right? This is the same process, okay? So 4i times 7i is going to be what? 28i squared. What did we always say about I squared, though? It becomes -1. So anytime you see I squared, you know it's becoming -1. And I know that this really means multiplication. So 28 times I squared, or 28 times -1, is really what? -28. Okay? Questions on that?
Yeah, back up. You lost me after you got the 28 I squared.
Okay, 28 I squared, and then we change I squared into -1. And then we know that that's really multiplication, 28 times -1. Okay, let's do 16. On 16, first, instead of doing all 3 across, we're going to do 2 at a time. So -4i times 2i. Miss Carolyn is in her room. Should be -8i squared. And then we're going to bring down our -9i next to it. Okay? But before we multiply by -9i, we have an I squared there. And we always need to deal with I squared when we see it. I squared is really, okay? So, hang on, think in your head. So this becomes -8 times -1, right? That's what that really becomes there?
No.
What is -8 times -1 then? 8. So now I have a positive 8 times -9i.
Wait, how'd you get the positive 8 out of that one?
Because I squared turns into what? -1, right? And then we multiply -1 times -8 to get a positive 8. Okay? What is 8 times -9i, do you think? -72i. Okay, we're going to hop down and do number 19. Actually, no, we're not. I'm just kidding. We're not. This is as far as I need you to go today, as far as I is concerned in this lesson. Okay? So we're going to take what we've learned. And I want you to do I want you to do 1 through 19 odd. So on homework 9, page 14. Page 14, homework 9. I want you to do 1 through 19 odd, but you may skip 7, and you may skip 13, but I want you to add in number 10. So that was kind of weird. So you should be doing 1, 3, 5, 7. I'm sorry. 1, 3, 5, 9, 10, 11, 15, 17, 19.
Wait, I'm confused.
Okay, I'm going to say it again. 1, 3, 5. So circle them. 1, 3, 5, 9, 10, 11, 15, 17, 19. 11, 15, 17, 19. I'm going to give you about 10 minutes to get started on it, and then we're going to move gears.